And then for part C, the answer is or the question is to find the junction depth x sub j, and that's equal to the square root of 4 dt natural log ln of q sub t, the dose, divided by Cv. So we have the Cb value, and Cb is concentration, is the intrinsic concentration of the wafer, or the concentration of boron, if we're assuming it was boron doped. I think that's why they used the B for that one. And then this is also, you'll notice there's another error in the book at this point. It should be divided by the square root of dt. And if you refer back to equation, the previous page, you'll see that equation 3.21 is, this is equation 3.21, and that has the square root of dt in the denominator. So that's another error in the example. Okay, so taking the square root of all that, and let's plug in the values. So xj equals the square root of 4 times dt, and so this is, let's see, in this case I'm going to stick with microns, and so our square root of dt value is 0.778 microns. If we square that, that's 0.60528. Okay, let's see. Get 0.60528 microns squared. Okay, so I can plug that in here. 0.60528 microns squared. And then natural log of qt, and our qt value was 6.99 times 10 to the 15th per square centimeter of our for our dose. And the Cb, remember, is given as the initial dopant in the wafer 1 times 10 to the 15th per cubic centimeter of the p-type. And then we have the square root of pi, that's just this number, 0.778 microns. Now remember, this is inside a log, so all my units are going to have to cancel, so I'll have to convert this to centimeters, so times 10 to the minus 4th centimeters. Okay, 10 to the minus 4th centimeters. Okay, and then when we're done with all that, we're going to take the square root of the whole thing. So, okay, so let's go through the calculator and do this calculation. And let's see, on this calculator you have to be a little bit careful about entering this. So I'm first going to calculate the stuff inside the natural log and make a note of that. So I have 6.99 e to the 15th, and I'm dividing by 1 e to the 15th, so I guess I could have just left that off. Then dividing by the square root of pi. I'm going to hit enter at this point and do a sub calculation, and then I'm going to divide by 0.778 e to the minus 4. And that gives me about 50,690. And so if I take the log of 50690, I'll go 50690. That's equal to 10.833. So I'm going to write that down. 10.833. And so next I need to multiply that by 4 times times 4, and also times 0.60528. 0.60528. And so that's 26. If I take the square root of that, 6, and enter, I get 5.0, and if I had included a few more digits, I would have gotten 5.016, wait, no, 5.124, but anyway, I get 5.0 for that microns, or close to that. If you included more digits, you'll have a slightly different number. And so the actual value of x sub j is that, and the last time I calculated this and included more digits, I got 5.124 microns. The answer in your book is given as 5.4 microns, which is a little bit off. Okay, a little bit off. Should be closer to this one. Okay, so that's part C of the problem.